All right, last day of pre-cal review here. So we're going to focus on some exponentials and logs. We are going to be giving our answers in decimal form today, so we will be using our calculator, but it does say use your calculator where needed. So we are going to solve these by hand rather than just plug them into the calculator and get an answer like that. That's a task we'll do at a later date because that is something that's important. You need to know how to do that for the AP exam, but we're going to focus on working by hand today. All right, so our first problem, we have an exponential equation. We want to get this x by itself, so our first task is going to be to get rid of the base, this e right here. So we learned an inverse operation for exponentials is a log. So I'm going to come up here and just do a little bit of side work. So you might have done a problem similar to this in the past. And so to get rid of that 2, you would have done a log with a base of 2. And then you would have done that on both sides, log with a base of 2. And so if we want to do e to the x equals 5, then it would make sense to do a log with a base of e on both sides like that. And that's exactly what we do, except we don't write it like that. A log with a base of e, and I'll just say of x, is the same thing as a natural log, ln of x. Okay, and so we use this natural log, which is the inverse operation of this e. So that's where we're going to start with here. We're going to put natural log around that. We're going to put natural log around this 75. And so I'm going to take you through a couple extra steps on this first problem, and then going forward, we won't do these extra steps in the future. So what's really happening here is that this 2x minus 3, there's a property of logs that if you have a log of something that's raised to an exponent, that exponent can be moved to the front. So that's what we're doing here. 2x minus 3. And then that's being multiplied by the natural log of e. And then on the other side, we have the natural log of 75. All right, and the natural log of e is 1. So you can think of it as like the natural log and the e are getting canceled out, and you're left with whatever the exponent is. So the exponent on an e is just a 1. All right, and that's why usually we skip this step that I just wrote, and we just say the natural log and the e up here canceled out, and then we're left with the 2x minus 3. Because 2x minus 3 times 1 is 2x minus 3. All right, a couple quick algebra steps, and then we have our answer. Natural log of 75 plus 3, and then all of that gets divided by 2. All right, and if you didn't have a calculator, this is the farthest you could go. We don't know what the natural log of 75 is off the top of our heads. That's what we use the calculator for. So if you have your calculator, you pull that up. You do a calculator page. I'm going to hit Control divided by, get a fraction, and then you can hit Control e to the x right there to get a natural log of 75 plus 3 divided by 2. I'm going to put a decimal point after that too, so I make sure I get decimal form, 3.659. College Board requires all decimal answers to be rounded correctly to 3 decimal places. And I say rounded because that's what I do, but truncating is also acceptable. So rounding is this 4th decimal place, the 7 rounds this up to a 9. That's how I did it. Truncating is just dropping everything after the 3rd one. So the College Board would have accepted 3.659 or 3.658. In this problem, I'm always going to round. That's just how I've always done it. So that's how I'm going to keep doing it, but you can choose whatever way you like better. All right, letter B. Hopefully kind of recognize this format from our lesson yesterday with the trig problems. This is a quadratic equation. We've got 3 terms, so we factor when we have a quadratic equation. And so e to the x multiplied by e to the x. And come up here and do a little more work. Remember your exponent rules. If you have like bases and you multiply the bases together, you add the exponent. So that's equal to e to the x plus x, which is e to the 2x. All right, and then we need to multiply to 10. So it could be a 1 and a 10, but more likely it's going to be a 2 and a 5, especially since we want to add up to 3. negative 3. So we want a negative 5 and a positive 2. And so we end up with e to the x equals negative 2. Subtract the 2 over, and e to the x is equal to 5. The e to the x function is always positive. So it crosses here at 0, 1, and it goes like that. So it's impossible for e to the x to be equal to negative 2, which would be down here, right there. That's not possible. If you do a natural log on both sides, which is how you solve this, you would get x equals the natural log of negative 2. And that's one of the domain things I talked about on the first day, that you're never allowed to have a negative number or a 0 inside a natural log. So if you ever end up with that natural log of a negative or natural log of 0, that doesn't exist. All right, so this one gives us no solution right there. This one we can solve in that same fashion, x equals natural log of 5. And that is the answer. And with our calculator, we can type this in. Natural log of 5. Oops, didn't get my control in there. Control e to the x, natural log of 5, decimal point 1.609. And in this situation, truncating and rounding give you the same result, 1.609. And so that would be the only solution College Board would accept as an answer. All right, letter C looks pretty similar to the last problem. It's got 3 terms, should make you think of a quadratic, but we don't have a 2x, we just have an x. We also have this negative exponent. That's a little weird. So we're going to do a little bit of algebra beforehand, and then it'll turn into a problem just like letter B. So an exponent rule that you need to remember is that negative exponents send that part of this term down to the denominator. So we're going to rewrite this as 12 divided by e to the x. And when it goes down to the denominator, it becomes a positive exponent. All right, so that seems like we made things worse, but what that does is it allows us to see what our next step could be. All right, we don't like having fractions like this, especially if we're trying to solve an equation. So the way we fix that is we multiply everything by e to the x. All right, and so e to the x times e to the x is e to the 2x. We talked about that above. And then with this term, e to the x times 12 over e to the x, the e to the x's will cancel out, leaving us with just the 12. And then minus 7 times e to the x, and then equals 0. Do a bit of rearranging here and get it in the same form the letter B was in. So e to the 2x minus 7 e to the x plus 12. And then we're ready to go with our factoring. So we have e to the x times e to the x. So it could be a 1 and a 12, could be a 2 and a 6, or it could be a 3 and a 4. And I wanted to add up to 7, so I'm going to go with the 3 and the 4. And they have to have the same sign because they have to multiply to a positive 12. And we need that to be a negative 7, so they're both going to be minuses. So I end up with e to the x equals 3 and e to the x equals 4. Both of those are positive numbers, which is good. That means that we can solve and get an answer in both. So I end up with x equals ln of 3 and x equals ln of 4. And so my decimal form of these answers would be, arrow up and copy that and just change my number to a 3. And one more time to a 4. So 1.099 and 1.386. All right, notice I put the wavy equal sign. That means that this is an approximate answer, which since we rounded it, it's approximate and not exact. No wavy equal sign up here because those are the exact answers. All right, next problem. Similar to how after we moved this down, we wanted to cancel out that denominator there, so we multiplied by it. That's what we do here. So we're going to multiply both sides by e to the x plus 3. So that's just going to cancel out with that e to the x plus 3, leaving us with 18. And then over here, we get 5 multiplied by e to the x plus 3. All right. I could have distributed that 5 in there, done it that way. That would be fine. Or I can just do my algebra from here. I don't think either way is easier or harder than the other. So I'm going to do it this way because this is the way I saw it first. But if you saw distributing and then working it out, that's great too. Be about the same amount of steps. So I'm going to divide by 5. And then subtract 3. All right, if you want to get picky about it, you can turn this 3 into a 15 over 5. So you get a common denominator, and then 18 minus 15 would be 3/5. And you get that. All right, then we take the natural log of both sides, and we end up with x equals the natural log of 3/5. All right, here I'm gonna change this and go up here. I want to say a little bit more about that answer before we plug it in the calculator. So x equals the natural log of 3/5. All right, so I mentioned the log property where if you have an exponent, you can bring that to the front on that first problem. So here's another log property that you'll need to remember. If you have a quotient is the argument of your log, you can turn this into a subtraction. So you can do natural log of 3 minus natural log of 5. And so since natural log of 5 is bigger than natural log of 3, if we subtract those numbers, we're going to get a negative answer. So that's what I wanted to point out. And so I knew that before I split it up, because I knew that this fraction with the numerator smaller than the denominator is automatically going to be a negative number. So it's just kind of nice to have that little expectation before you plug something in the calculator. You're thinking, okay, I should get an answer that looks like this. So if you were to plug it in incorrectly or make a typo or something and you got an answer that was positive instead of negative, you had that expectation in your head and you can correct a mistake. If you're just blindly plugging stuff in the calculator and writing down the answer without thinking very much, then you're going to be prone to make mistakes with the calculator, and we want to avoid that as much as possible. All right, so I'm doing my natural log of 3 divided by 5, put my decimal there, and there we go, negative answer, negative 0.511. That 8 will round it up. So x is approximately equal to negative 0.511. All right, so the other version of this type of problem is where we start with a log, and we have to get our x in there. So the way that we do this is we call it exponentiating. And so to get rid of this natural log, just like we used a natural log to get rid of an e, right? I didn't write it when I did this earlier, but we do natural log on both sides like that. So to get rid of a natural log, we use an e. So we use an e like this, and the natural log becomes the exponent of e. So I like to write the little caret symbol to signify this is an exponent. I'm not multiplying by e. E is the base. Natural log is now the exponent of that base. The word for this is exponentiate. And we do that over here as well, e to the 5th power. All right, so what happens here? There's not really any fancy rules that I want to talk about. So we're just going to do this. E and the natural log cancel, leaves you with 3x minus 2. And then over here, we get e to the 5th, which is not a number you're expected to know. That's what the calculator is for. Do our couple steps of algebra. We add 2, we divide by 3. So we get e to the 5th plus 2 all over 3. And now that's as far as you can take it without a calculator. So we can plug this in and see what we get. So I'm going to hit that control divided by again to get my fraction template. Okay, you never want to type the letter E like that. See how it's like this italics? You can get that down here on the keypad, E. That doesn't work. That's not the E we're talking about. You have to use this E to the X button right here. See how it's bold and a little bit different font? Okay, you can also get an E from this menu over here. It's right next to H. It's got a pi symbol on it, and there's an E right there. But if you do that, you don't get the exponent part, and we want an exponent. We want e to the 5th. So e to the 5th, like that. And I talk so much, I forgot what the rest is. So plus 2 over 3. Decimal, get decimal form, so 50.138. All right, so now they've changed it on us. Now we don't have an LM, we have a log. All right, when they write just the word log, they have to give us a base. All right, so if you ever get a log and they don't give you a base, that's called a common log. So this one over here is a natural log. This is called a common log. Common logs have a base of 10. Okay, in the old calculators, common logs and natural logs are the only two you can plug in. Nowadays, we have fancier calculators. We can plug in log base 5 and log base 4 like these other examples have. But in the past, everything had to be turned into a common log or a natural log. So that's why it has a name, and that's why you see it on a lot of problems. All right, now we're trying to cancel out this common log. So we used a E for the natural log because E and natural log are inverses of each other. All right, remember we talked about log base E and E to the X canceling each other out. So here, a log base 2 and a 2 cancel each other out. So a log base 10 and a 10 base will cancel each other out. So instead of E to the power of natural log, we're doing 10 to the power of log base 10. And we do that over here as well. Okay, so that and that will cancel. 4x plus 3. And this one we can actually do without a calculator. 10 squared is 100. And so I think we can just solve this one all the way. Subtract 3 is 97. Let me put my 4 back there, and then we'll divide by 4. Oops, 97 over 4. And fractions are great. I'm happy with a fraction. If you are desperate to put it in decimal form, what would that be? 21 point. No, it's not 21. That's done. Let's try something better. Let's see. 4 goes into 17 4 times, 24, and then there'd be 1 left over, so 0.25. And if you get an exact decimal like this, you do not have to put a 0 to make it 3 decimal places. You only have to do 3 decimal places if it rounds to 3. So that's kind of why I wanted to talk about this decimal right here, is you can leave it just like that because it's an exact decimal. All right, 24.25 exactly. All right, next one. So if you have multiple logs on the same side of an equation, so 2 logs on the left side, you have to combine those together into 1 log. Okay, so we're going to use a property. I told you about the quotient property up here. If you have a quotient, you can turn it into a subtraction. So that's the property we're actually going to use on letter H right here. So if you have a sum of logs, you can turn that into a product. So we get log base 5. Then we're going to have our x plus 3 multiplied by x minus 2 is equal to log base 5 of 14. All right, we're going to go ahead and multiply that out. Log base 5, so x times x is x squared, and then we have 3x minus 2x, which is 1x, and 3 times negative 2 is negative 6. All right, so now we can go through the whole, you're going to use a 5 base to cancel out the log, but since you have a log base 5 on both sides, you can just take whatever's inside those logs and set that equal to each other, and that's going to be our equation. All right, this is a quadratic equation, so we'll need to get it equal to 0, so I'm going to subtract the 14, which gives me a minus 20. That factors into x plus 5 times x minus 4. And so we end up with x equals 5 and x equals negative 5 and x equals positive 4. Oh, one more thing. Sometimes with log problems, you get extraneous solutions. So you have to make sure that if you plug these answers back into the original problem, you cannot have a negative inside a log. We talked about that earlier. So if I plug in negative 5 plus 3, that's a negative. That would be log of negative 2. And that's going to be undefined. So you can't do any math with that. So we actually have to throw out this x equals negative 5. That doesn't work. If I plug in 4, I get 4 plus 3 is 7. That's good. 4 minus 2 is 2, which is also good. So x equals 4 is going to be the only viable solution for that. Okay, you want not all solutions to be extraneous. Both of them could work. Neither of them could work. You could end up with a no solution situation. So you just always have to plug it back in and make sure that whatever solution you got doesn't give you a negative or a zero inside the log. You're not allowed to have a negative or a zero. All right, so H is very similar, except we're going to have to use the quotient property. So this is going to turn into log base 4 of 2x plus 1 divided by x minus 2 is equal to 1. All right, and then this time we can't just say set this equal to that, because this side doesn't have a log over here. So we actually have to go through that process where we exponentiate. So 4 becomes the base, log becomes the exponent, 4 becomes the base, 1 becomes the exponent. So over here, those are going to cancel, and we get 2x plus 1 divided by x minus 2. And over here, we get just a 4. All right, so now to solve this, we need to start by canceling out our denominator. So we're going to multiply by x minus 2. So those are going to cancel right there, giving me 2x plus 1. And then I'm going to go ahead and distribute over here, so I get 4x minus 8. And I'm going to subtract 2x over here and add 8. So 9 is equal to 2x. So x is equal to 9 halves. Okay, once again, make sure you plug this back in, and you cannot get a negative or a 0. So if I plug it in here, 9 halves times 2 would be 9, plus 1 is 10. That's good. 9 halves minus 2 is bigger than 1. It's not negative, so that's good. That's all we need to check. All right, last problem. We're going to look at this kind of more complicated thing and just do a bit of a word problem. This type of word problem is very popular. Once we learn how to do some calculus, you will do calculus to create this function yourself, and then you will do some math with it afterwards. So you have that to look forward to. We're just going to do the Precal version that y'all know how to do already. So this equation represents the population of bears in a national park after T years. We want to know how many bears were there after 2 years. Okay, so we're going to start using a little function notation here. The function is called P. We want to evaluate P at the number 2. So this is P of 2. And we're simply just plugging in 2 to this. Pretty easy. You would not be expected to evaluate anything like this without a calculator. So just like that. And you plug it in. And that's it. All right, so we get 160. And the control divided by, I get my fraction, is 1 plus e to the negative 0.3 parentheses 2. Double check, I typed everything in right. Forgot my 7 in front of the e, so let me go back and put that in there. 7. All right, should be good. So 33.046. All right, now you can't have 046 of a bear, so you can round that off to a whole number, and we'll write our answer as a sentence because it's a word problem, and usually the College Board likes a sentence as an answer. So we can say there are approximately 33 bears in the park at 2 years. I said at, maybe after, since that's how they worded it, after 2 years. All right, anytime you're doing a written response like this, you want to think of the acronym NUT, N-U-T. This stands for noun, unit, and time. Okay, so time is usually, well, we're good. This is going to fit. So there are approximately 33 bears. All right, that's your noun. In the park after, and then bears are your units. And then 2 years is your time. So you want to have a noun, a unit, and a time in every written response. All right, letter B. After how many years will there be 50 bears in the park? So 50 bears would be P is equal to 50. So now we're trying to figure out T when we know P. So let's set this up. 50 is equal to 160 over 1 plus 7e to the negative 0.3t. All right, now I'm going to go through this by hand just because I like doing that. I like solving equations, but I'll also show you all how to solve this one strictly in the calculator, which most likely if you're on an AP exam and you have something like this will be a calculator problem. All right, but if you're working it by hand, you want to start by multiplying by the denominator. You'll notice that we do that pretty much every time there is a denominator. We're going to multiply by it. So I end up with 50 times 1 plus 7e to the negative 0.3t is equal to 160. I'm divide by 50. And we can cancel out those zeros. So I end up with 1 plus 7e to the negative 0.3t is equal to 16 fifths. I'm going to subtract my 1 over. Come over here. So I get 7e to the negative 0.3t is equal to, all right, 16 over 5 minus 5 over 5. 1 is 5 over 5, so that would be 11 over 5. All right, I'm going to multiply everything by 1/7. That's going to cancel out that 7. E to the negative 0.3t is equal to 11 over 35. Now we're going to take a natural log on both sides to get rid of my e. So I get negative 0.3t is equal to natural log of 11 over 35. Now I'm starting to think to myself, all right, that is a negative number. We talked about that before because it's got a fraction in there. Numerator is smaller than the denominator. And then to finish this off, I'm going to be dividing by a negative number. Now, if you think about t is in years. So should you ever get a negative number as an answer for years? No, definitely not. Okay, so I better be getting a positive number here. And I know even before I type this in, this is as far as I'm going to take it by hand. We'll type this in the calculator. But I know even before typing this in, this is a positive number because I know this natural log is negative. I know I'm dividing by a negative. So a negative divided by a negative is going to be a positive. All right, so let's type this in and see what we get. So hit my control divided by to get my fraction, natural log of 11 over 35. And then on the bottom, negative 0.3. So 3.858. And that's in years. And we don't round off years because you can have 0.858 of a year. So there, or let's see, it takes approximately 3.858 years for there to be 50 bears in the park. So this one kind of flies in the face of my NUT algorithm a bit because our time is actually our noun because that's what we were trying to find. Your noun is what you're trying to find. So 3.858 years is your noun. Years is your unit. And then your time in this case is the 50 bears. That's what they gave you. Time is what they gave you. Noun is what you were trying to find. And then units are your unit on your noun. All right, so I said I would show y'all how to solve this one just strictly with the calculator so you wouldn't go through any of these steps. If this is on the calculator part of the exam, this is how I would tell you to do it. I would never have you solve anything by hand if you have a calculator to use instead. Okay, so we have this equation, 50 equals this. So I always solve things on a graph. So I got to open up a new page here, Control Doc, graph page. So you want to type one side of the equation into F1. So that's my 50. I'm going to type the other side of my equation. I'm going to hit Control divided by. And 160 over 1 plus 7e negative 0.3. And then you can't use t, you have to use x in the graph. So negative 0.3x. All right, so we can see that, but we can't see 50 up here. So you can actually just click on this guy right here and just type in 50 if you like. That's still not quite it. I should have typed a little bit higher, but you can just drag this up and down too. You can also go to menu 4, which is window zoom, and then number 1 is window settings, and you can set your Y maximum right there. do whatever you like. So I'm just going to keep it where it is now. And what you're looking for is that intersection point right there. That's where they're equal to each other. And so you go to menu, you go to analyze graph, which is number 6, and you go to intersection, which is number 4. And you just need to click on the left and the right. And you can see 50 is the y value because that's what we set it equal to. And there's our x value right there, 3.858, same as we got before. All right, hope you enjoyed the video. And good luck on worksheet number 3.